right, so our new topic is something called nested loops. All right, so if you think back to math, you've probably heard the term nested functions before, but it's basically where we put a loop inside of another loop. And we're going to see why that's useful and then what it's going to allow us to do, especially in regards to altering and changing pictures. So it's kind of hard to tell on a black and white copy, but this baby has red eyes. And you've probably seen that before. If you take a photograph, sometimes people's eyes show up red. So thus far, we've been using this loop, 4p in get pixels picked. And what that does is it goes through every single pixel in the picture. So if we use this code, it would reduce the red in every single pixel. But we might not want to reduce it in every single pixel. We might want to be able to target a small section of it. So maybe we only want to reduce the red in this section and this section. So this is where we want to reduce the red. All right. Again, this loop's not going to do it because that loop's going to go through every single pixel. But we're going to see that with nested loops, we're going to be able to target our modifications. Instead of having to do the modification to everything, we'll be able to target specific parts of the picture and do different modifications to different sections. All right, so that's going to be the general idea. That's where we're headed with this. All right, so to do this, we're going to have to take advantage of a Python function called range. All right, and range returns, just looks like an R there. All right, so returns a sequence, or I'm also going to use the word list of integers between two values. Okay. So if we were to put this into our computer right now, and if you were in front of me, we probably would put it into our computer right now. What you're going to see is this is going to print out 1, 2, and 3. All right. If we were to do this one, it would print out -1, 0, 1, and 2. And I encourage you not to take my word for it. All right. Bring up REPL, type this in, verify that you're getting the same thing that I'm writing here. All right. Now on this one, list range 1, 10, 2, I would get 1, 3, 5, 7, and 9. And then on this last one, I would get 0, 1, and 2. All right. So based on that output, let's try to figure out what's kind of happening here. All right. So it seems pretty clear that the first number we put in is where our list or where our sequence of numbers is going to start off. So this one started off at 1, this one started off at -1, this one started off at 1. All right, we'll get to the last one in a second. But basically, the first number that we put in is where our list is going to start. All right, the next thing we notice is that the second number, it never quite gets to it. All right, so I put in a 4 here, but it only does 1, 2, and 3. I put in a 3, but it only gets up to 2. I put in a 10 here, but it stops at 9. Right? So what do we notice? The high end value is never reached. So if you do a range from 1 to 4, you don't actually get to 4. It's basically 1 to less than 4. If you provide a third input, so here we have 1, 2, 3 inputs instead of just 1, 2 inputs, 1, 2 inputs. If you provide a third input, specifies what you count up by. All right, with the default being just 1. So if you don't specify anything, it's just going to go up by 1. But we can put something in there and have it go up by different amounts. Now, on this last one here, we can see that if you only provide one input, it treats that as the upper limit, and then it automatically starts at 0. So if you only provide one input, it assumes you want to start at 0, right? So this is going to be really important, this range function, when we start to set up our nested for loops. And you're going to see in a little bit why it's going to be important, but it's going to be helpful for us to set up these nested loops and target specific sections of the picture. All right, so let's do a little practice with this just to make sure that we kind of understand how it works. So we have some code here, def mystery 1. We have a loop. It says for index in range. Now remember, this index here, this is not a special word in Python, right? This is just our loop variable, all right? For is a special word that has to be there. In is a special word that has to be there. We just learned about range, but remember, index is our loop variable. It didn't have to be called index there. That was just the choice for this sort of sample code that we're looking at. Now, this range 1, 6, notice that I'm not including this list here. All right, that was just for purposes of printing it out. All right, if we're not printing it out, we can just say in range 1, 6. And we know that this means it's going to start at 1. It's going to go to 2, 3, 4, and 5. All right, it's going to create a sequence of those numbers. It's not going to get up to 6. So as this loop functions, index is first going to get the value 1, then it's going to get the value 2, then it's going to get the value 3, then it's going to get the value 4, then it's going to get the value 5. So it's just going to work through this list one at a time. So altogether, this code right here is going to repeat 5 times. All right, again, 1, 2, 3, 4, 5. All right, notice that this is not indented. All right, so because this is not indented, it's not in the loop, which means this part, this part is only going to happen once. All right, so it's a little different than the stuff that's inside of here. So what we're going to do is we're going to trace this. So you run this function. The first value for index is going to be 1. Num is going to be 6 minus index, so 6 minus 1, or 5. And then since we're printing out num, the output is just the number 5. All right. Then we loop back up. Index now goes to our second piece here, which is a 2. Num now gets the value 6 minus 2, or 4, and then we print out num. And I think you can kind of see what's happening here. So then index is going to be 3. All right, 6 minus 3 is going to be 3. We're going to print out 3. Then index is going to go up to 4. 6 minus 4 is 2. And then we're going to print out a 2. Then index is going to go to 5. 6 minus 5 is 1. And then we're going to be printing out a 1. And then last but not least, that ends the loop because there's nothing left in our list. So we go down to the next line of our program. And in that next line, we're just printing out the words blast off. All right. So that's, again, just kind of tracing it. All right. So let's try another one here. All right. It'd be a good idea to try this on your own. So I would pause the video, try it on your own, see what you end up with. But after you've tried that, I will go over it. So again, we have for index in range 1, 4. So that tells us that this list is going to have a 1 in it, a 2 in it, a 3 in it. It will not have a 4. All right. So when this code executes, all right, we enter this, print index is a number. And what you should have seen in lab 1 is that we can't do a number plus a string. So what this is doing is it's turning that number into a string so that we can combine these together. So we've got an index of 1. So this is going to then say 1 cat. Then the index goes to 2. And then it's going to say 2 cat. Then the index goes to 3. And it's going to say 3 cat. And then the loop is going to end. And only when the loop ends will we print out the phrase crazy cat lady. Though I would make the argument that you need way more than 3 cats to be considered a crazy cat lady. You've at least got to be like approaching double digits. You don't have to quite be there. I think you might get there once you're up to like 7 or 8 cats, but you got to at least be near double digits. All right. So we're kind of slowly building this to get up. So let's see what we've got next. All right, we've got some more practice ones here to just, again, get used to this idea of ranges and what's happening. So I'm going to, again, encourage you to try these on your own. All right, pause the video, try them on your own, and then we'll see how we did. All right, so for k in range, because remember, I don't have to use the word index. This loop variable can be whatever I want it to be. So this is going to make my list 1, 2, 3, 4. All right, so k is going to start off at 1, but then I'm going to be printing out 2 times 1, so my output's going to be 2. Then k is going to go to 2. I'm going to print out 2 times 2, which is going to give me 4. Then k is going to go to 3. 3 times 2 is 6. K is going to go to 4. 4 times 2 is 8. The loop is going to end, and only then will I print out who do you appreciate. All right. So here we're starting off with result, and it's just being set basically to empty quotes. So there's nothing inside of it, but it is making it so that it's a string because we're putting those quotes there. So it's basically saying, hey, This is being set up as a string, but it's currently empty. There's nothing in there, right? Our range is going to go from 3 to 4 to 5 to 6 to 7. Again, it won't get up to 8. Now, this one's a little interesting because we're not actually printing anything out in here. All right, so S is going to start off at 3. Result is going to be equal to whatever it used to be plus a star. So the very first time result was empty. So we're basically just saying do empty plus a star. So the only thing that's going to be in there is a single star. And then again, we're not outputting anything. All right, then we go to 4. This time when we do the calculation, there's already a star inside. So it's basically saying star plus star, which is going to give us 2 stars. And again, we're still not printing anything out. Then we go to 5. Now it's going to be 2 stars plus 1 star, and we're going to get 3 stars. So we can kind of see the pattern here. We're just adding a star to our result variable each time. So S is going to be 6, and then we're going to get up to 4 stars. S is going to be 7. We're going to get up to 5 stars. And then once the loop ends, and not until the loop ends, do we actually print those out and print out the 5 stars that are part of that variable. Okay. All right. Let's keep going here. All right. So again, these take some getting used to. I'd rather practice one too many than one too few. All right. So again, pause the video, give these a try. You know, if you weren't comfortable enough to do the last two, maybe you're more comfortable now, try these two. But again, you need to try these on your own, because if all you're doing is watching me, it's going to be hard when you actually have to do it in a program or on a test. Okay, so this time we have a variable called sum. It is set to 0. We're doing 4K in range, right? 1 to 7, which means we are getting 1, 2, 3, 4, 5, and 6. We are not getting up to 7. And then we have this code in here that says sum equals sum plus k. All right, so let's see what we have here. First time k is going to be 1. Sum started off at 0. So this is basically saying 0 plus 1. And we're restoring that in sum. So now sum's going to have the value 1 in it. And again, the print statement is outside of the loop, so we're not printing anything out. All right, then we loop back up. K goes to 2. Now we're doing, remember, sum now has a 1 in it, so we're doing 1 plus 2 to give us the value 3. All right, we're still not printing anything out, but then K goes to 3. Sum now has 3 in it from the last time through the loop, so it's going to be 3 plus 3, which gives us 6. And then K goes to 4, and it's going to be 6 plus 4, which gives us 10. Then K goes to 5. It's going to be 10 plus 5, which gives us 15. And then K goes to 6, and 15 plus 6 is going to give us the 21. All right. At that point, the loop comes to an end because our range is over. And then once the loop comes to an end, we finally do print out the value inside of sum, which is just 21. All right, let's take a look at this one over here. for S in range. Again, there was nothing special about index. There was nothing special about K. This is the letter or the word that you choose. This is your variable in the range 1 to 7, which again is basically the same as the last one, meaning 1 through 6. We don't actually get to 7. Right. This is saying print the string X times whatever number is inside of S. And again, we saw this very early on in Python, but if you do X times 4, you'll just get 4 X's. If you do X times 10, you'll get 10 X's. So let's trace this and kind of think about what we'd get. So when S is 1, we're doing X times 1, which means we're just going to get that single X. And again, it doesn't print out with the quotes. I'm just putting the quotes there to designate that it's a string. I'll probably drop them on the next one. All right, next time, S is going to go to 2. Now, we didn't save this in a variable, all right? We're just printing it out, so it's still just a single X times 2, which means it's going to give us 2 X's. And then when it goes to 3, it's still just a single X times 3, so we're getting 3 X's. And then we're going to get 4 X's. And then we're going to get 5 X's. And it makes this little triangle shape. And then we're going to get 6 X's. But we're not going to get 7 X's because, again, our list stops right here. Right? So this is our stopping point. All right, so now that we've done a bunch with single loops and this range, let's take a look at the nested loop, right? And we'll see sort of what happens when you put a loop inside of another loop, right? So you'll see here, we've got our function. Here's our first loop. Here's our second loop. So this one has a range of 1, 4, which means it's going from 1 to 2 to 3 and then stopping. It doesn't get to 4. This one has a range of 5, 7, which means that it gets to 5 and 6 and then nothing else. All right. Also notice that this whole thing is indented under our first for loop. All right, so this code is all part of that first for loop. So this entire loop is going to get repeated every time this loop gets repeated. All right, so let's see what actually that's going to play out as. So when K is 1, J is going to have to go through and do 5 and 6 because that's what's part of their range. All right. When K then moves up to 2, J is going to have to do 5 and 6 again. Right? When K goes up to 3, J is going to have to do 5 and 6 a third time. All right? But every time this runs once, this loop has to do its entire execution. All right? And then this loop runs again, and this loop has to do its entire execution. All right, so if we're tracing this, all right, K starts off at 1, J starts off at 5. So when we print out K plus J, we're going to get the output of 6. All right, then we stay stuck in this loop. All right, we don't get out of this loop. We're stuck in this loop. So J is going to go to 6. But K stays the same because we're still stuck inside of this loop. So we're going to be doing 6 plus 1, and we're getting 7. Right? Once J gets to 6, this loop is over, and we get to go back up to this loop. All right, so this one runs, and then when it's over, we go back up here. So now K can go to 2, and J gets reset to 5 because this has to start from the beginning because it's now coming back down to it, which is going to give us an output of 7. And then J is going to go to 6, but we're going to still keep K at 2 because we're stuck there. And we're going to go to 8. Once we get to 6, that inner loop is done. So we get to go back up to the top where K is going to become 3. All right. J is going to get reset to 5. So we're going to end up with an 8 here. Then J is going to become 6. K is going to stay the same because, again, we're stuck inside of this loop. And 6 plus 3 is going to give us 9. All right, so we can see that putting a loop inside of a loop, the code's going to run quite a few times. All right, we actually outputted 6 different values, even though this one was running 3 times and this one was only running 2 times. But basically, 2 times here, 2 times here, 2 times here gave us the 6 total outputs. All right, so let's practice some of these now to make sure that we kind of understand how these are going to work. All right, so I've got 4K in range, 1 comma 4. So I think early on, it's very helpful just to write these out. So 1 comma 4 means 1, 2, and 3. 4J in range, 0 comma K plus 1. All right, so this is interesting. This is different than what we've seen before. But this right here is going to make the repetitions vary. Right? They're going to change each time because instead of putting a straight number in there, we're putting in a variable. All right, so when K equals 1, the very first time it goes, J is going to be going from 0 to 1 plus 1 or 0 to 2. So J is only going to give us 0 comma 1. Right? Because it's going to be a range of 0 to 2. All right. When K equals 2, our range is still going to be 0, but now it's going to go up to 3, which means J is only going to give us 0, 1, and 2. All right. And then when K equals 3, all right, that's going to mean that our range is from 0 to 4. So J is going to be 0, 1, 2, and 3. Because again, we don't actually get up to 4. Right? So let's actually trace this now. All right, so K is 0, J is 0, and we're printing out J, so our output is J. All right. Next, J is going to go to 1. Right? Because remember, our initial one was 1 plus 1, so our range was 0 to 2, so we're going to get 0 and 1. So now J goes up to 1, and we print out a 1. At this point, our inner loop has completed. All right, so our inner loop has completed at this point. So then we go back out to the outer loop, and K goes up to 2, and J goes back to 0, and we print out a 0. Then J goes to 1, and we print out the 1. This time, J is going to get up to 2, because again, when we did this calculation, it was no longer 1 plus 1, it was 2 plus 1. So J is going to get up to 2. We're going to print out a 2. All right. At this point, the inner loop is going to be complete. So we go back to the outer loop, which allows K to change to 3. All right. So if K is 3, we're going to be doing 0 comma 4, which means we do 0, 1, 2, and 3. So J is going to be 0, and we're going to print out 0. J is going to be 1. We're going to print out 1. J is going to be 2. We'll print out 2. J is going to be 3. We print out 3. And then that brings us to the end of these loops. So you don't necessarily have to put a constant in here. You can put some sort of calculation or variable, and then your inner loop can actually run different amounts of times based on how the outer loop is changing. All right. So it's just kind of another way you can sort of manipulate these. And we're going to see that doing this sort of thing can allow you to alter different sections and target different parts of the picture. All right, so this would be another one for you to now try to practice on your own. As far as this print statement is concerned, don't get overwhelmed. All this is saying is it's going to print out the variable k. Then it's actually going to print out the letter x because it's inside of quotes. So there'll be a space, the letter x, a space. Then it's going to print out the variable j. Then it's going to go back to printing out regular text. So a space, an equal sign, another space. And then it's going to print out k times j. So this is just letting us go back and forth between regular text that's inside of quotation marks and variables that don't have any quotation marks around them. Right? So again, try it on your own, and then you can come back and see if you got the same thing I did. All right. So what we have here is we have a range from 1 to 6, which we now know is 1, 2, 3, 4, 5. And we have a range from 1 to 4, which is really 1, 2, 3. So the first loop is going to start. K is going to be 1. J is going to be 1. And it's going to print out 1 times 1 equals 1. Okay. Then J is going to go up, but K is going to stay the same. So J will go to 2, and it'll be 1 times 2 equals 2. J will go to 3. It'll be 1 times 3 equals 3. At this point, the inner loop has finished. So now we go back to the outer loop, and we're going to get 2. The inner loop's going to go back to 1, and we get 2 times 1 equals 2. Then this goes to 2. 2 times 2 equals 4. Then this goes to 3. 2 times 3 equals 6. Again, at this point, the inner loop has finished. So now we're back to the outside. 3 times 1 equals 3. 3 times 2 equals 6. 3 times 3 equals 9. And at this point, I'm going to stop because it just goes on and on and on and on. All right. I'm not going to write out all, the table here, but I'm just going to say and on and on and on. But what I am going to do is I am going to put the very last one. So at the very final one, K is going to be 5. Remember, it doesn't actually get up to 6. J will be 3 because it doesn't actually get up to 4. And you'll have 5 times 3 equals 15. Okay. All righty. So let's take a look at this sheet. So instead of tracing here, each one of these has an error. All right. It has a mistake somewhere in it. So your goal is going to be to try to identify the mistake. So again, pause the video and try to figure out the mistake in each of these, functions that include a loop inside of them. All right, so first one, all right, the mistake that we're seeing here is that this is improperly indented. So this should actually be over here, all right? There's no, we do indent when we're going inside of a loop, but this is all part of the same program. This is all part of the same function. So result and for should have the same indentation. So this is an indentation problem. And you've been seeing that every now and then because you'll accidentally not have something indented, or you'll accidentally have something indented and your program's not working. So you just have to make sure that you have things properly indented. Now, as far as what this program is actually doing, All right, we've seen this sort of program before where it's just kind of building up the stars. So again, this is going to go 4, 5, 6, 7, 8, 9. And each time it's adding a star to this result variable. So it's taking what was there before and then adding a new one and then printing it out. So first time it would print out 1 star, then it would print out 2 stars, 3 stars, and so on and so forth. All right, it's running 1, 2, 3, 4, 5, 6 times. So eventually you would get down to having 6 complete stars. All right. All right. On this one, where's the mistake? Right here. All right. Anytime you create a function, you need to have parentheses. So this one is missing the parentheses. Even if you're not putting anything inside of those parentheses, remember, this is where we put our inputs. Even if you don't have any, you still have to have the empty parentheses there to designate it. And then again, this one would be going from 1, 2, and 3. This one would be going 1, 2, 3, and 4. And again, this one's a little trickier because what's happening here is that this is making result empty. Then we go through and build up the stars. So we say result equals result plus star. So it's going to build up 4 stars, but we don't print it until we're done. All right, so I would print out 4 stars. Then I go back up to the top here. I go to the second one. Result gets cleared out, so it's emptied. All of those stars are cleared out. Then we go back and build up the 4 stars again. And then once that loop has been over and we built up the stars, we would print it out. And then the same thing would happen one more time. And we'd end up with a little 4x3 box here. Because again, this one's only running 3 times. So we'd end up with those right there. All right, last but not least. All right, what's going on this one? And in some ways, I think this one was the most obvious. But right here, these two were backwards. All right, so it should have been starting at 0 and going to 5. So we've got this one, which is going 0, 1, 2. And then we've got this one, which is going, once you fix it, 0, 1, 2, 3, and 4. All right. Now, as far as what this is doing, it's basically starting by printing a C. All right, so at the start, it's going to print a C. That's the first letter that it prints, and that's not part of a loop or anything. Then it's going to print the B. Then it's going to go inside of this loop and print 1, 2, 3, 4, 5 A's. So 1, 2, 3, 4, 5 A's. Now, this is where you have to be careful and you have to pay attention to the indentation. This loop ends. Note that this print statement is not inside of the outer loop. So when we're done here, we go up to this. The C wouldn't actually get printed out. The C is not going to get printed out until this loop is over. This is all kind of one thing together. So that C would not happen until this part had finished. So instead, we'd get another B, we'd get another 5 A's, and so on and so forth there. And actually, I should be stating that these would be going down, but I was going to run out of room if they went down, so I'm just kind of printing them all on the same line. But each time you do a print, it does put it on a new line. So this is just my way of showing you the letters that are being printed. but it's not actually what would show up on the screen. So then you get another 1, 2, 3, 4, 5 A's. You'd get your third and final B. You get another 1, 2, 3, 4, 5 A's, and then eventually you get your C there at the end. Okay. So you didn't have to this part you didn't have to do, but I just kind of wanted to show it to you in case you were curious. Because who's not curious? I mean, come on. It's pretty much the most exciting thing you could imagine. A bunch of programs that print out random numbers and stars. All right, so let's tie this back to pictures, because that's really the whole point. Like we started this saying, like, oh, we want to sometimes modify just small sections of pictures. So how does this all tie back? So a quick review is when you have your picture, you have coordinates. So the top left coordinate would be 0, 0. As you go to the right, x gets bigger. As you go down, y gets larger. Now, if this picture was 640 pixels tall and 480 pixels wide, you'd have to remember that this coordinate right here would actually be 0, 639. All right, 640 tall, yes, but since you're counting 0, it maxes out at 639. All right, same thing over here. Yes, it's 480 pixels wide, but that means you'd actually max out at 479 pixels. And then same thing down here. All right, even though it's 480 by 640 or 640 by 480, we're only getting to 479, 639. And again, the reason for that is we're starting with 0. So that sort of subtracts 1 when we're talking about the pixel location. Yes, there are 480 pixels, but they are numbered 0 to 479. Yes, there's 640 pixels, but they're numbered 0 to 639. All right, so it's important to keep that in mind, because when we're setting up our loops, we have to make sure that we don't go outside of the picture. All right, if we go outside of the picture, that's going to cause problems and cause our program to crash. So we have to make sure we stay inside of the picture. All right, so hopefully you're seeing where this is going. But we can use the range function that we've just been using for the past, 10 or 15 slides to work our way through a picture. All right, so we can start our range at 0, and then we can go to height -1 and width -1, and that will allow us to navigate through the picture. All right, and if we don't start at 0 and we start at something else, that'll let us modify a specific part of the picture. Now, to modify like a block of the picture, we're going to need more than one loop. Each for loop can only change one variable, and we're going to need 2 for a matrix. All right, we're going to need 1 for the x coordinate and 1 for the y coordinate. So this is how everything we've just been doing is going to suddenly translate over to pictures and being able to modify and target specific locations in our pictures. So let's take a look at an example here. So this says looping across pixels with range. To use range, we'll use nested loops, 1 to walk the width, 1 to walk the height. All right, so if we look at this, it says 4x in range, 0 to get width of picture. So let's just pretend we had a 100 by 100 picture. All right. Well, what we just talked about on the last slide is that if we have a 100 by 100 picture, the bottom right pixel is only going to be 99.99. All right. the top left pixel is going to be 0, 0. Now, on the previous 10 slides, you might have been saying, it's really kind of annoying how range doesn't actually go up to that last number. It stops one short. But actually, most things in computers start with a 0, right? Just like our pixels here. So it turns out this is going to be really helpful because let's say my picture was 100 by 100. This is going to do a range from 0 to 100, which is actually only going to go from 0 to 99. Same thing down here. If I say a range from 0 to get height, and the get height is 100, it's only going to go to 99, just like I need it to. All right, so this range, yes, it cuts one off that last. You don't go up to the last number, but since most things in a computer start at 0, that actually ends up being sort of really helpful for us. All right, so what we have going on here is we've got this inner loop that's going to go and navigate the Y's, and then we have this outer loop that's going to go and navigate the X. So this code right here is going to get 1 pixel at the designated coordinates. And then this one is, getting the red value. Once you have the pixel, we're getting the red value, and then we're doubling it. You've seen this sort of thing before. But what's happening here is for each X value, because that outer loop is going to have X changing, and it's going to go from 0 to 1 to 2 to ... however big your picture is. The inner loop goes through every single Y value. All right. So if we want to visualize what that looks like, X is staying at 0, but then we're going through all the Y values. Then X moves over to 1, and we're going through all the Y values. Then X goes over to 2, so 0, 1, 2, and we go through all the Y values. So we're working through the picture one sort of column at a time. All right. If we had flip-flopped this and made the Y the outer loop and the X the inner loop, then we would have been going across instead of up and down. And you can do it either way. Now, kind of taking this the next step, this is going through the entire picture, but by playing with these numbers, we can start going through specific part of the pictures instead of doing everything all at once. All right, so let's look at another example here. All right, it's actually a similar example, but we're gonna make it a little more concrete. All right, so here's our imaginary picture that has a width of 6 and a height of 3. And you can think of each of these boxes as just an individual pixel. All right, so we've got our function here, x in range, 0.getWidth. So get width is going to be 6, which is going to give us 0, 1, 2, 3, 4, and 5. All right. For y in get range, get height is 3, which is then going to give us 0, 1, and 2. And then what we're doing is, again, we're getting the pixel, we're getting its red value, and we're doubling it. So we're going to trace this just like we were tracing it before. So x is going to be 0 at the start. Y is going to be 0 at the start. So we're getting pixel 0, 0. Right? So the first pixel we're modifying is this one right here. Then y goes up by 1. X stays the same because it's part of that outer loop. All right, this loop has to finish before this can change. So Y will go to 1, we'll go to 0, 1, and this pixel will happen next. Then Y will go to 2, we'll be at 0, 2, and then this pixel will happen next. At this point, our inner loop is finished. So this will go to 1. This will get reset to 0. We'll go to the coordinates 1, 0, which means this box is happening next. And then you can kind of start to see what's happening here. This is going to be 1, 1. So this will happen next. You can rewrite one there. I actually don't like to do it because it makes it easier to see that like outer loop, inner loop. So 1, 2, which is going to be 6. At this point, the inner loop is finished. So we go to 2, 0, which would be this box is the 7th one that gets modified. Then 2, 1, then 2, 2, and so on and so forth. But we can see we're going 7, 8, 9. This would be 10, 11, 12, 13, 14, 15, and then 16, 17, 18. All right, so that's how it's actually sort of moving through the picture and just changing it pixel by pixel by pixel. All right, so now let's look at one where instead of changing the entire picture, we start to specify where we want our code to run. All right, so same thing, same setup here. All right, only now I'm not using get height and get width. I'm putting in specific values. So I've got a range right here that's going to start at 1 and stop at 2. And then I've got a range right here that's going to start at 2 and stop at 4. But this code is pretty much all the same. I'm going to those coordinates. I'm getting the red value, and I'm setting the red value. Now, you do have to be a little careful here because notice this time I'm putting my Y as my outer loop, and I'm putting my X as the inner loop. All right, so at the very start, Y is 1, X is 2, so I'm placing something at coordinate 2, 1. All right, if this is 0, 0, this is 1, this is 2. If this is 0, this is 1. So this would be the first box or first pixel that I'm modifying. Now again, this time the Y is my outer loop. So it's not the Y that's going to change. It's the X that's going to change. All right, so now I'm going to coordinate 3, 1, which is right over here. So this time, because I put the Y on the outside, instead of going down the columns, I'm going across the rows and moving through the picture that way. So this might be where Y is 1. This is where Y is 2. And this one actually doesn't even have a third one, so I'm not going to label it. But that's the idea. This time we're moving horizontally through the picture. All right, now we do have one more here because X goes all the way up to 4, which puts us at 4, 1, which means this is the third pixel that we're modifying. At this point, our X loop has finished, so we go back up to our Y loop, and now it can finally change to 2. X gets reset and has to run through its loop again, so now we're at 2, 2. Then the X increases, and we're at 3, 2. And then the X increases again, and we're at 4, 2, which puts us at 4, 5, and 6. And again, if you're kind of wondering what's going on here with the numbers, just remember, this would be 0, this would be 1, this would be 2, this would be 3, this would be 4, this would be 5, and then the same thing going down. This would be 0, 1, and 2. So you have to remember that first one is 0, 0, not 1, 1. Okay. And again, obviously, these are your X's and these are your Y's. All right, let's keep going. I mean, these are just too much fun not to keep going. All right. Increase red for picture. Mid equals get width. Picture. Divide 2. Now, we did this probably the very first day we did Python, but you may not remember it. This is how we do integer division. And the big thing with integer division is that it truncates all decimals. And truncate means that it cuts it off, so it doesn't round it up. It basically automatically rounds it down. Or you can just think of it as it cuts it off. It like basically pretends there's no decimal there. Now, in this case, it doesn't actually matter because 6 divided by 2 is going to give you 3 regardless. But if my width had been an odd number, it would have been a decimal. And then that would have caused problems when you were setting up your range because your range doesn't work with decimals. It wants sort of integer values there. All right. So just be aware that if you're doing something like this, you should always use the double division just to make sure there's no decimals because we don't want to have decimals inside of our range here. All right. So we want to make sure that the min and the max for our range are integers. All right. So where were we? Oh, so yeah. Oh, try this on your own. Pause the video, and then you can come back and see how you did. All right. So again, if we're kind of going through this, let's start by just labeling our grid here to make it easier. 0, 1, 2, 3, 4, 5. 0, 1, 2. These are our y's. These are our x's. All right. It tells us the width is 6. We could also count that. So mid is going to end up with 3 inside of it. All right. This is going to result in 3 being stored in mid. So since we're using mid here, this is a range from 0 to 3, which effectively means we're getting 0, 1, and 2. Now, this is a range from 0 to get height. Get height is 3, which means our range is only going from 0, 1 to 2, just like the outer loop is. So both loops are going from 0 to 1 to 2. Now, as far as how we move through the picture, you have to make sure you're paying attention to the outer loop versus the inner loop. So the outer loop is our x, so that's going to stay 0. And then our inner loop is going to go 0, 1, 2. Once that finishes, our outer loop is going to go up. And then our inner loop gets reset and goes 0, 1, 2. And then that finishes, our outer loop goes up, our inner loop gets reset and goes 0, 1, 2. All right, so our coordinates would just be 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, and 2, 2. Okay. So in terms of how we're moving through the picture, all right, 0, 0 is here. 0, 1 is here, then here, then here, then here, then here, then here, then here, and then here. So this is basically code that processes just the left half of the image. So instead of processing the entire image, this is how we could process just the left half of the image. Now, try to think about it. What if you wanted to process just the right half of the image? So instead of the left half, how would you need to change this if you only wanted to process the right half of the image? All right, so instead of starting at 0, we'd have to start at mid, because remember, mid was 3. So we would start at 3. And then instead of finishing at mid, we would finish at get width. So we would start at mid and then go to the end of the picture. So again, left half, right half. So you could do the same sort of thing here with the height. You could do the top half or the bottom half by just playing with these values and only modifying specific pieces. All right. Again, it's important that we just practice these, all right? They take some getting used to, so the more practice, the better. All right, so again, I'm going to encourage you. Trace this out. Try to follow the code. Do it on your own, and then come back and check to see how you did. All right, just watching this through is not going to help you when you have to write code and take a test. All right, so we have our picture. Again, I'm going to throw on the coordinates just to make sure we don't make a silly mistake. 0, 1, 2, 3. These are my X's. These are my Y's. All right, the range is from 1 to get width of picture minus 1. So that means my range is from 1 to 5 because the width of the picture was 6. And if my range is 1 to 5, that means the numbers that I'm getting are 1, 2, 3, and 4. All right, so there's a lot to kind of keep track there and make sure that you keep straight in your head with the minus ones and the ranges and all of this and that. All right, for the Y, again, we're starting at 1. We're going to get height of picture minus 1. The height of picture is 4. So we're going from 1 to 3, which really means our list is only going to be 1, 2. Right? Because we don't actually get up to that final number there. All right, so if you go through these too quickly, you tend to make a mistake and just say, oh, 1, 2, 3, or oh, 1, 2, 3, 4, 5. You have to kind of stop yourself and really force yourself to think about that range so that you don't goof it up. All right, second thing we have to make sure we pay attention to is the outer loop versus the inner loop. So the X is our outer loop. So that goes and starts at 1. And then the Y loop has to finish before we change the X. So Y will go from 1 to 2. Then the X can change and become 2. The Y gets reset and goes to 1 to 2. The X goes up. The Y gets reset and goes from 1 to 2. The X goes up. The Y gets reset and goes from 1 to 2. And then again, we can just list these as coordinates. This is 1, 1, 1, 2, 2, 1, 2, 2, 3, 1, 3, 2, 4, 1, 4, 2. And now we translate that over to the picture. So 1, 1 is right here. This would be the first box that we're altering, right? And then 1, 2 would be down here. So this is when we're removing down the columns, not across the rows. 2, 1, 2, 2, 3, 1, 3, 2, 4, 1, 4, 2. All right. So again, you can see how we can use this to target specific places in our picture instead of having to do the whole thing. All right, nested loop challenge. Finish the following function, which should put a 50 by 100 green rectangle in a picture starting at pixel 50, 50. All right, so let's sketch this out so that we can understand what this is actually asking for. All right, so let's pretend this is our picture. And it's saying you want to make a rectangle starting at pixel 50, 50. So let's just pretend that right here is pixel 50, 50. All right, that means our X has gone over to pixel 50. Our Y has gone down to pixel 50, 50. And then at this point, you're drawing or creating a rectangle that's 50 by 100. All right, so 50 tall and 100 wide. So again, we're making a green rectangle that has 50 here, 50 tall, and 100 here. All right, so think about where that would go to. And then think about what numbers you're going to have to fill in here to make this shaded green rectangle. Because again, all the code is doing is getting the pixel and setting the color to green. So whatever was there is just getting wiped away, and we're just making sort of a green rectangle. All right, so think about it for a second, pause the video, and then come back and see if you were correct. All right, so our range would want to start at 50. And then this is the X. So our X is going to need to be 100 long. So we're going to go from 50 to 150. And you might be saying to yourself, wait, 150 is only going to bring us to 149. But again, since we're counting 50 as our starting point, this is going to give us 100 pixels. So when we do this, this gives us 100 pixels, even though it's only going from 50 to 149. That's 100 separate pixels that it's modifying. And then the same thing down here for the Y range. We're going to start at 50, and we're going to go to 100. And again, it'll stop at pixel 99 or whatever, but that gives us 50 pixels. So it's just going through these one by one, all these little pixels, and coloring them green to make your rectangle there. Now, what if the picture was too small? All right, what if my picture doesn't have an X coordinate of 150? What if my picture doesn't have a Y coordinate of 100? What if I put numbers in there that are larger than my picture? What's going to happen? You're going to get a runtime error, and your program will crash. All right, so if your program's crashing when you're setting up with one of these, it might be that you've used numbers in here that are actually going outside of the bounds of the picture. So it's always important to know the height and width of your picture when you're doing this type of coding so that you don't go outside of those heights and widths. All right. Almost done here. Last two slides. So here's an effect that we can write code to do. All right, we can mirror horizontally, or we can mirror vertically, and we can do that using code that we already are familiar with, and we can do that using the nested loop. So everything, you have the ability to do this, you just might not realize it yet. All right, so let's look at a program that will actually mirror things, and let's talk about how it works, just to make sure it's clear. All right, so this function is called mirror vertically. All right, it starts by getting the width and doing that integer division that we just talked about. All right, and then it gets the width. All right, so we've got both of those pieces of information stored in separate variables. One is called the mirror point, which is basically where we're flipping, and the other is just the total width. Now, again, we're going to use this little practice picture here. So we have a width of 4, and we have a height of 2, just for our little practice picture that we're working on here. So let's kind of walk through this code and see what's actually going to happen. So mirror point is going to do get width divided by 2. So mirror point is going to have a 2 in it. All right, width is just going to have a 4 in it, all right, because that's the width of our picture. Now this is saying 4y in range from 0 to get height. Well, get height is 2, which means this loop is going to go from 0 to 1, right? This is 2, but we never get to that, so it only goes from 0 to 1. This loop, 4x in range, 0 to mirror point, well, we know that mirror point is 2, so this one is also going to go from 0 to 1, all right? The mirror point is our halfway point. So let's take a look at our code here. All right, left pixel equals get pixel of x and y. So the very first time we run this, y is going to be 0, x is going to be 0. So left pixel is going to be 0, 0. All right, no problems there. Right pixel is going to be width minus x minus 1. All right, so let's think about that for a second. The width is 4, but even though the width is 4, we know that pixels only go from 0, 1, 2, and 3. And even though the height's 2, we know they only go from 0 and 1. All right, so let's ignore the x for a second. And if we just focus on this as width minus 1, that's basically giving us the final pixel. All right, because if the width is 4, 4 minus 1 is giving us the final pixel. So that's going to put us to the rightmost pixel. All right. Now, by subtracting x, we're going to be getting a slightly different pixel each time. So the very first time, it's going to be 4 minus 0, because x is 0, minus 1, which is going to give us a pixel of 3. All right. And that's coming from 4 minus 0 minus 1. All right, that's where that 3 is coming from. Now the y is just the y, which we know from our outer loop is 0. All right. Then our inner loop continues. This goes to 1. So our left pixel is 1, 0. All right, be careful that you don't flip these, even though normally x comes first. X does come first here. We just have them flipped in our columns here because the y is our outer loop. So just make sure that you're keeping that straight. And then over here, this time we're doing 4. We're no longer subtracting 0 because x is now 1. We still subtract the 1 because that's hard-coded in, and we get 2. So this is going to be 2, 0. Right. At this point, our inner loop has finished. So we go to our outer loop, which is 1. And then this gets reset to 0. So our left pixel is 0, 1. All right. Here we're back to doing 4 minus 0 minus 1, or 3. So this time we're 3, 1. And then this goes to 1. So we're at 1, 1. And then here we're now doing 4 minus 1 minus 1, which is 2. So that's going to put us at 2, 1. Right? So that's how x and y is changing. That's how left and right pixel is changing. Now, let's focus on what's actually happening. All right, so this is saying get the color of the left pixel and save it in this variable color. Then this is saying, all right, set the color of the right pixel to this variable color, which is effectively the left pixel. So left pixel is basically being copied over onto right pixel. So we're clearing out what was ever in right pixel, and we're placing left pixel in that spot. So let's actually kind of go down here so that you can see what's happening. All right, so left pixel at the very start was 0, 0. All right, the very first time we had 0, 0. This was left pixel. So 0, 0. This was our left pixel. All right, we're retrieving the color of this pixel, and then we're setting it to right pixel, which the very first time through the loop was 3, 0. This was our right pixel. So what this code is doing is it's taking this color and it's copying it over to this spot right here. All right, then left pixel becomes 1, 0, and it gets copied over to 2, 0. All right, so this would be our right pixel. So it keeps taking one and copying it over to the other side, taking one, copying it over to the other side. It's almost like you find your mirror point, and then it's like you're folding the picture across that mirror point so that these colors end up over here, this color ends up over here, all along that dividing line that you created. All right, and then it just continues. All right, this was left pixel 0, 1, and it gets copied over to right pixel 3, 1. And then the same thing here. All right, this was left pixel 1, 1, and it gets copied over to right pixel 2, 1. All right. So all this code is doing is it's basically taking these colors and copying them over across some sort of dividing line that's been set up. All right. So again, you're actually going to do a lot more with this in the next lab. All right. You're gonna mess around with different mirroring stuff, but this is just sort of an explanation of how it works and what's actually happening. So you're not just like blindly typing in code and being like, oh, look, cool, it did that. This gives you some understanding of why it's doing what it's doing. Okay. So kind of like last summary here, or big idea summary, is that by putting loops inside of loops and using this range function, we're able to target specific parts of our picture and modify individual sections, and also do things like mirroring by focusing on just certain sides of the picture and different effects that are possible through that. All right. So again, you'll get to explore this more in the lab, but this should sort of walk you through and give you a starting point to approach that stuff. All right. Have a great day, and I will see you when I see you.